Hello everyone, we are going to realize the recipe setup, also the tuning, set up the value and also tuning the best process condition with our product. Usually set up the recipe. Responsible is process engineer, but the equipment engineer also have to realize it works. This is the basic workbench structure. We have the tank 1, 2, 3, 4, 5 until 211. 1 is HF 49% chemical. 2 is DIW super clean water, and the number 3 is SC1 chemical. 4 DI water tank. 5 FC2 chemical. 6 DI water. 7 solvent chemical. 8 DI water. 9 final rings. 10 resist rings. 11 dryer. Tank 1, 3, 5, 7. They are chemical tanks. And final rings means after DI water tank, wash out the wafer to remove the chemical residue. The final rings tank will spray and rinse the wafer again to make sure the DI water rings is okay. And the final rings, after the final rings, we usually use the resist rings to let the wafer put in this tank. Use the water resist value meter to detect its water resist value. If the wafer is still dirty with chemical residue, then the water be polluted and the resist value will be small. Use this tank and we can see the wafer if is clean or not, to make sure the wafer surface is clean. 11 tank is dryer. As we talk about it, the dryer may be the IPA vapor or Mahagoni function to make the wafer dry. Other tanks are all DI water tank. The DI water tank to clean the chemical residue before it. This is the normal workbench figure arrangement. Now the recipe setup edit. For example, easy way just like below. We have to set the sequence. For example, the sequence is 1, 2, 3, 4, 9, 10, 11. It means that the wafer will go start to the tank 1 process, then go to the tank 2, DI water clean, then go to the tank 3, SC1 chemical, then go to the tank 4, DI water clean, then go to the tank 9 to do the final rings to make wafer more clean, then go to the tank 10 to make sure the wafer is out of the chemical residue. Then go to the tank 11 to dry the wafer, make it be dry to unload. This is the sequence. Then we have a sequence. Then we have set up every tank process temperature. For example, tank 1 set it to 30 degrees, and tank 3 we set it at 35 degrees. After we set up whole process temperature, then we set up the tank, the process time. Sequence, temperature, length time. For example, wafer into the tank 1. The process time we set the 90 seconds. Then wafer will stay in the tank 1 for 90 seconds. Then remove to the next tank. And we set the tank 3 150 seconds. The wafer after tank 1 process, it will go to the tank 2 DI water clean to remove the residue. Then go to the wafer, go to the tank 3 to be processed in 150 seconds. So this is the tank process time. Then we set the tank concentration. For example, tank 7 solvent tank. We set it is made up by alpha chemical 10%, beta chemical 90%. To do the process to suitable for the product. Then the high-end equipment, or we can say that expensive equipment, have the vibration device. The vibration device also put here, the process tank, as we talked about before. Wafer into this tank, and the vibration device will make the solution vibration to increase its chemical reactive. So we can set the vibration device, we can set its frequency, vibration frequency, or vibration time to increase the chemical reaction. And every DI water tank, we can set the spray water to the wafer to clean the wafer time, and set the rinse time. Rinse means that the wafer just sink in the DI water to be silent clean. We can set the time. This is the most basic recipe setup sequence. Some tools have more complicated recipe and a device to do the process. So the PE engineer, process engineer, need to know, understand all the meaning and the EE equipment engineer got to know all the meaning and its mechanical. If during the process the product is not be treated so well, probably the recipe is good, but the mechanical have something wrong. Equipment engineer have to take care of it to solve the issue. So the EE have to know the recipe as well as process engineer. Okay, that's all. See you next time.